Hey, everybody. It's about 5:45. We're going to start with we'll start with the program at about 6 o'clock. So about 15 minutes or so. Just, help yourself to the food. Most of you are already. Drinks are wherever drinks are, and we'll kick off in about 15 minutes. Thanks. Test. Hey, everybody. Hey, thank you for coming, everybody. Thank you for coming. I know, we're not sure what the weather's going to do, but if it does something interesting, we'll have a great view of it if it happens in the next hour or two. So that's kind of neat. Hopefully we can avoid what happened to Dallas, last week, or Houston a week or two ago and stuff like that. But if not, we're all here together and we got lots of food and beer, so we'll be fine. We'll be fine. My name is Brent. I'm your host for tonight. I work here at PMG. Director of AI. We are trying to, PMG, what is PMG? We were founded about 14 years ago or so, digital marketing agency headquartered up in Dallas, but we opened up this office a few years ago, and we're kind of, coming out of COVID and all that kind of stuff. We're trying to rebuild the communities that existed, either here in Austin or up in Dallas. Digital marketing agency, we've got some pretty decent technology, pretty decent data. We have a lot of really interesting clients. You can see a lot of them here and stuff like that. So we're handling a lot of ads, a lot of data. I think at one point I heard that we've touched about 20% of the ads on the internet. So that's at any given time about 1 billion people are looking at one of our ads, which is kind of nice. And we have a lot of the data behind that. So we're, with all that data, like everyone else, we're leaning in, trying to look at machine learning and AI and understand how we can be a little bit more efficient and a little bit more focused on our clients, a little bit more efficient for our clients, I guess. We're also building a community. I mentioned that. Part of that community is this, getting us all together, being able to talk, meet each other, link in with each other, greet each other, be nice to each other, those sorts of things. But, I would be remiss if I didn't say that this is also sort of a recruiting event for us. I won't point out who our recruiters are, but, oh God, I just got to stretch a little bit, and they might be wearing a PMG shirt or maybe not. I don't know. But, we're always hiring. We're always looking for solid people to come and help us make the world safe for digital marketing. Part of that is introducing our first speaker. It is Seth. Darn it, I didn't get his last name. Seth Hammock. He's been to a couple of these over the last couple of months, and I managed to convince him to come and tell his story, and he's going to tell the story about practical speech AI. So, Seth, over to you.
Thank you, Brent. And I'm going to have Jordan over here. He's going to function as my clicker. I tried to automate it, but it didn't work. So he's going to do the clicking. My name is Seth Hammock. Thank you all for being here. I'm the CEO of GOSIGNIFY, which is an online marketplace that seamlessly connects interpreters with law firms. It operates in several cities throughout the US, and it features hundreds of interpreters who offer their services in legal and medical in dozens of languages. As the CEO of GoSignify, I wear lots of hats like most entrepreneurs. I write code, I design web pages, I manage infrastructure, developers, I do fundraising and outreach like this. Let's see. There we go. Okay. So GoSignify is also looking for an exit. And as I started investigating new roles in deep learning recently, I stumbled upon this great thing called AI Camp. And this is the 7th one I've been to. I always feel very excited coming to these. I meet great people. It's usually the conversations after the meetings that are the best ones, where I really meet people who are enthusiastic about whatever it is they're doing. It just happens to be AI around here, right? Let me see. I have some notes here so I don't get off track. As you can see, so the deep learning specialization is something I finished earlier. It took me about 9 months to do that. For any of you investigating and getting into AI. How many people here consider themselves to be kind of beginners or intermediate in AI, or maybe you're, yeah? It takes a long time to learn. It's very complex mathematics. At Baylor, I studied mathematics as well, along with my degree in computer science. But it is doable. And with enough time and enough passion, you can do it too. And lastly, about GOSIGNIFY, I graduated from the Founder Institute last year, and the Founder Institute is here in Austin. And it basically teaches you how to pitch and do fundraising. And so as a result of that, I pitched to the John Brumley Venture Lab at the University of Texas and was accepted into their fall cohort. And so I worked with 8 grad students refining ideas like speech-to-text AI and language services. So this is a image of our application. I work with interpreters from all over the world. And these interpreters have to pass federal and state background checks. They have to pass rigorous exams. They're American Sign Language, Spanish, Igbo, Quiche, all kinds of indigenous languages. And so a lot of the interpreters started to reach out to me in November of 2022. And I had been using the Microsoft Azure Speech API in my own practice in courtrooms before that. Now, the accuracy wasn't great. I still enjoyed learning how to use it and studying the natural language processing behind it, but it wasn't all that accurate. It was basically like a real-time thesaurus sometimes. And especially whenever they, it would make mistakes and I wouldn't catch myself between wound and injury in Spanish, herida y lesión. And so I said, no, it's not a wound, it's an injury. So, I had to really keep up with what I was making sure that I was translating right. So to that end, I am a licensed court interpreter for Spanish and English. I spent a lot of time in Bolivia. I've spent a lot of time in Latin America and also Bangladesh and India, where I worked on State Department projects and international development. So a lot of the interpreters would ask me, what's going to happen to my job? There was a lot of talk about this. As you might imagine, it's pretty contentious within this professional community. Now, we often hear about people saying, hey, AI is going to take my job, accountants, you name it. But as far as I can tell, a lot of jobs are pretty safe for the time being. This is one area where it's really impactful and people are really actively searching for ways to integrate it into their professional workflow. And so, as you might imagine, in high stakes conversations, there's a lot of issues that come up. The response rate is 1. Speech to text requires a really strong internet signal. If you don't have that, you're going to go beyond the 320 milliseconds, which is kind of a benchmark for how quickly humans respond during a conversation. Now, what's amazing is that the recent release of ChatGPT, the 4 Omega, actually is hitting rates around 280 milliseconds, which is insane. So this just kind of deepens everyone's anxiety around it, but there's still issues that come up, right? There's the acoustic interference. A lot of times there is old courtrooms, or there are law firms where there's construction going on outside or something like that. Of course, crosstalk and arguing is always fun for everybody during litigation. There's vocabulary issues that come up that I just mentioned. And this is always my favorite: dialect, speech impediments, and level of sobriety. And so you would be surprised that the AI does not do real well when somebody is being magistrated in front of a judge who has had a 12-pack. So that's where live human interpreters really make a big difference. And of course, puns and sarcasm, those are unique to human intelligence. Those are unlikely to be dominated by AI anytime soon. Though whenever the new models come out of Facebook, for example, the JEPA models that are going to add computer vision to the multimodal language models, that may have effect. I don't know. So I use this translation app that I built apart from GoSignify. I do still interpret. Within my community, it's really important to be part of the interpreter community. They're typically very suspicious of people outside of the community. So I recruited everyone on the platform. Most likely I've spoken to them at some point. So I built this on my own to use in my own practice. And this is the QR code to my GitHub where I have that. If you want to check that out, give it a star, if nothing else, I'd appreciate it. So as I mentioned before, I use the Azure Speech AI API, and I save all of my conversations to MongoDB. And then I use those to do some fine tuning. For example, one of the challenges in Spanish, most people have heard Spanish. We're in Texas, so yeah, I mean, you've heard of Espanol, right? So in Spanish, it's pretty simple compared to something like Korean or Russian, where you have what's called honorific tenses. So there may be 5 or 6 of those. If we have any Ukrainian speakers in here, I'm sure we do. If Vlad's around, he could probably tell you. So it's very simple. There's formal and informal. And so I can take the conversations where it's using the to form, which it shouldn't do in a legal setting. It should use the formal conjugation, and I can train those models to respond properly, so it's more accurate for the setting. And then I go through there and I train it using like low rank adaptation using something like TensorFlow. So I'm going to show you this hit it again, Jordan. You might need to play it again. Up, back, too many times. So once we get this kind of go forward to the first video, there you go. These two, if you can get that playing out, you might need to click in the middle of the screen. I'm not sure. Uh-oh. Technical support. Hey. There we go. Okay. Yeah. I mean, obviously you all have seen speech to text work. So I'm not going to be so ridiculous as to show you an example, like a live example, like I was telling Roberto earlier. We all know that it works. But I chose this banal example because what's really interesting, since the latest versions of the Azure API and some of the other APIs too have been updated, you have the young woman here, and she's asking a question in English, and the gentleman below is answering in Spanish. However, you see that it's actually recognizing which language is being spoken. Now, ideally, I'd like to have those flipped. I've been working on that. So if it's Spanish first, it would come at the top, right? But it's still detecting which language is being spoken, which is huge in my context, right? Because a lot of times I'm interpreting between a litigant or somebody who's in trouble, and they're speaking, the judge or the attorney speaking English, and then suddenly, the defendant or the litigant has to respond in Spanish. And some of these settings will go on for hours, right? So this has been huge for the profession. We can actually interpret for more accurately for longer, which is something that just wasn't possible before. We're going to go to the next example, which is Varys and Tyrion, sorry, from Game of Thrones. And I'm showing you this one because I'm going to show you an example of the context window. So in blue up here, what you're going to see is the context window. You always hear about this with AI. It is context window, context window. It's an important idea. So what the application does is it actually compares two buffers from what's coming in and so it stores it, and then it compares it with the updated translation. So the way that it works is context windows work by taking the most recent information, updating what came before on the newest information, right? So it's giving you the best guess based on the latest information. So what you have here is the best guesses that are real time. Now these are coming through at 300 milliseconds, right? These are coming through at 300 milliseconds, and then these are basically going to be when it detects silence. And so it's going to print out its best guess right here. And it actually does pretty well. I don't know. Sounds kind of strange to me here. I don't know. But this is these are British actors. So, but that's the idea behind the context window. And that's a really, really important idea as you go forward, especially when talking about transformers and natural language processing. Okay, so we're going to take a little bit of a deep dive here. Look under the hood. How many people have heard of convolutional neural networks? Okay, these basically underlie most of the modern AI that we're dealing with. And I had an engineer tell me the other day that came from geology. So convolutions are is a matrix operation. And so what you're seeing here is you're seeing a filter being passed over this, the smaller filter being passed over this larger filter here in front. And you're basically just multiplying these values as you go along. And usually what happens is it results in a smaller matrix. Now, the reason they're doing this is for demonstration purposes. These matrices are the same size, but the idea is to compress the information, right? So you're compressing the information. Now, people say, why are you showing an image of, if convolutional neural networks are principally used in computer vision, why are you using them with speech to text API? And that's because about a year ago, they discovered that doing convolutional neural networks over the images of like this would be a sound clip, for example. For those, this is the hertz, this is decibels, this is the time, right? This is a short clip. I don't know what it says, maybe hello, who knows? But you're basically passing this filter one row at a time, just like you see over there, and it's coming up with a compressed version of it. And so these convolutions are really important to almost everything that we do when it comes to training neural networks. And so you'll hear a lot about these if you've been studying or if you haven't yet. This is a really important idea. Now, is anybody afraid of math here? I don't think so. So you have straight matrix multiplication here. But here about 2 years ago, they discovered that if you do a matrix transpose operation on these, you actually gain about 10x in compute efficiency, which is crazy. So, I mean, the mathematics is driving all of the AI. It's just an idea, right? Now they're then taking these ideas for these mathematical operations and adapting it to hardware like the GPUs, which is they specialize in this kind of matrix multiplication. Yeah. Oh, okay, great. So I'm using the Azure Speech API. I have the most experience with that since about 2018, but you can you can basically cobble together an automatic speech recognition model and a neural machine translation model. This is an example right of Hugging Face. And it's become so incredibly easy to do. It's almost shocking. When I started studying computer science 20 years ago, I've determined that I'm not old. I was just really, really young. That's how I look at it. And so this is a simple example of how you can just use a few lines and put together one of these speech translation models. Thanks. These are two popular. These are very easy. This is basically a single line of code to create your first convolutional layer. What I just showed you in the images before. I use TensorFlow. I have most experience in that, but PyTorch as well. As you can see, they're basically the same. The number of filters, you have 3 channels here. This would be the shape of the image you saw there, 28 by 28. Now this assumes that it's black and white because there's only one channel. If it were multicolor, it would be 3 channels, red, green, blue. But you can see that it's very simple to put these things together, right? I mean, the complexity behind it is mind-boggling, and yet they've reduced it to just a few lines of code. Okay, so where is the speech to text going? Within the legal community, a lot of the concern is what happens when a minor is speaking? What happens whenever there's private information that gets revealed during some type of litigation or something like that. And this happens all the time, right? It could happen with your kids, you know, Siri's listening, Alexa's listening, right? Those are all serious risks, especially for litigation, right? Huge liability. So the quantization trend that started is a really important one because it allows, it's going to allow for the production of retail consumer devices that just run large language models. It's pretty amazing. The size reduction that they're getting with the Llama 7B and some of the larger Llama models 70B by using the quantization, and instead of using like int32s for the vectors, I hope I'm not boring you with all this, but with int32 and the vectors, you're using like 8-bit integers. So you're just reducing the amounts, the number of bits that you're using to store your model weights. Lower power consumption, which is huge too for cell phones. And I've read that the idea is to get us all the way back to running on CPUs again, which should be amazing. And as far as the multimodal LLMs, Mark Zuckerberg has done a pretty amazing job. He actually, those are both of his projects. Seamless M4T is on Hugging Face, and it's mind-boggling. It's incredible. And so what the multimodal LLMs is going to do is basically make for easier pipelines. Instead of using 2 or 3 models to accomplish something, you can use just one, right? And you're going to be able to have the reduced latency because you're not having these models on big servers talk to one another. And so that ultimately makes them very scalable. So last but not least, I always feel like when I come to these, people want to learn. I mean, people want to learn how this stuff works. And I feel like every time I speak to someone, I'm usually sharing some information. So these 2 books here are ones that I keep as a regular reference. They are very good. And I've read about probably, I haven't read them. Let's say I've checked out about 20 books. These 2 are the winners. I don't need to read very much to know which ones are the winner or the losers. These are very good. The deep learning specialization went all the way when I started with this book. I covered everything up to chapter 24, right, with that deep learning specialization. That's Andrew Ng with Stanford University. Very, very good program. Yeah, toward data science is also, if you're not checking out Medium, the Medium, I don't know what that is. It's a media company, I think. They have all these publications, $5 a month, and you get all of the articles written by people in toward data science. And those are a gold mine. I mean, I spend a lot of time on toward data science, public library, and then meetups like this. And last but not least is archive.org. All the seminal papers, attention is all you need. Transformers, convolutional nets on images for sound samples, all of that is going to come through there first. So that's it. This is my QR code for my LinkedIn. If you want to ping me, I'd love to talk to you. And thank you so much for your time and enjoy your evening.
Thank you. Thank you, Emily. This is Emily Fox, everyone. She's the one who made this happen. I'm not going to lie. She really did. Any questions for Seth? They're in the.
Appreciate it. Oh yeah. If you have questions, I always forgot that part.
So I haven't got my hands on one yet, but the Microsoft Surface, the new ones that have the NPU on it, what do you think of that for local processing and voice for your application domain?
You know, I haven't really done much experience. I haven't done much experimenting really with TPUs or NPUs very much. I pretty much, so whenever you're learning this stuff, iterating is absolutely key. So when I first started like training models on that MacBook 2017, it said 3 days and 45 minutes. You know, it's like you're not going to learn very fast doing that. So my rationale was basically go to Google Colab and just pay to use the GPUs so I can iterate as fast as possible and I can see when models are failing or not. Any more questions about anything?
I have a bit of a funny question.
Right.
I noticed you put the public library up there. I'm wondering exactly how you use it. I found it to be like maybe not that useful when I was looking for like technology books recently.
Yeah, I mean, they have quite a few. Well, they don't have enough copies of those two books. So I have a secret that I won't share with you around why I still have those books. But essentially, they need to buy more books because people are really wanting to learn this stuff. And of course, 3 weeks is not long enough. I mean, by a long shot. So the reality is that I'm going to wind up just buying those books. I've had them for so long, but they took away late fees, so I can be a delinquent. What do you know? Anybody else? Bueller? Anybody? Bueller? All right, back to you, Brent.
Thank you, Seth. If you guys were here, I'm just the interim entertainment while we get the next guy, Steven, set up for his talk. I think so. I don't know. Oh, okay. Sumanyu, you ready? Are you going to be ready? Okay. All right. You'll be last, Steve. You'll be last. If you were here last month, you might have seen a PMG guy talk about locally hosting models and stuff like that, right? And Seth was talking about locally hosting via Ollama, which means that we're actually putting together a highly curated, very intentional set of these talks. They all fit together. They don't fit together. They're just anybody who wants to come and talk and can come and talk. You also saw Seth kind of give out his LinkedIn code, and that's part of building a community, right? So if you're sitting next to somebody, feel free to, link in with them and talk to them and stuff like that. Because that's a really important part of building this. This is a series. We do these once a month. The first one in here was, I think, in January, and we've had them ever since then. We will have another one at the end of, in about 4 weeks. And what I'm going to ask is a couple of things, 4 things from you guys in decreasing order of importance before we get Sumanyu going here. One, right now, take photos, share, tag them, put them out on social media because we all know how network effects work. If you come back on 6/27, that's when the next one here in Austin will be. If you do come back, the second most important thing would be to come back with a friend, right? Bring somebody here who might be interested in talking. And then the most important thing, frankly, would be to come back, bring a friend, and tell a talk, right? That's what Sumanyu did. He came here a week ago, or last month, and now he's giving a talk, and he's going to be talking about Hammock AI, which is going to be we have 2 CEOs back to back here. That's pretty amazing. He's going to be talking about how Hammock can help us reduce hallucinations and gain better trust in LLMs going forward. Thank you.
Testing 1, 2, 3. This is good. Great. Thank you, Brent, Emily. I guess Vlad's not here, for having me here. Excited to chat. I am building a company called Hammock, and our mission is to make AI reliable for all enterprises. A little bit about me. I am Canadian. Any Canadians in the house here? Canadian. Oh, nice. Perfect. Oh, sick. Nice. All right. Solo. I went to the University of Waterloo. I specialized in machine learning there. As a student, I published a first author paper in medical image search, where I stacked 2 autoencoders together to create an embedding for an image, very similar to the embeddings that we're using these days. The idea was to help clinicians upload X-rays or MRIs and find other similar, clinically similar X-rays and MRIs of other patients to make their decision process more efficient and to reduce error rate. That was the research I was doing during undergrad. I spent several years in the Bay Area. I ran machine learning powered growth programs at Tesla, worked very closely with Elon's team there. One of the programs I scaled to hundreds of millions in revenue per year in top line growth. It was mostly luck, a little bit of skill. I have to be honest there. After that, I was the head of data at a company called Citizen that sends you crime alerts based on location. Do you guys have the app? Any users there? Nice. That's some background. A little bit about Hammock. We are doing YC in the summer, so I'll be skipping the Austin heat strategically. Yes. So I talk to 10 to 20 companies per week, and all of them tell me, hey, I have this great idea or set of ideas or POCs. I'm struggling to make them reliable. Help. I think if 2023 was a year of demos and POCs, I think 2024 and moving forward is the year of reliability. I think the bar for what consumers and users expect from AI systems will only increase every year. Moving fast and breaking things doesn't really work here. Unreliable AI, I think, has massive, massive brand risk. I'm sure you guys have seen what happened to Air Canada. They were basically held legally liable for anything that their chatbot was outputting. That's a very high bar for accuracy. And now it's encoded in law, at least in Canada. And I'm sure you've seen a lot of people trolling right on Twitter. Unsophisticated, unrobust chatbots buying cars for $1, and other antics. I'm sure you've seen this. The foundational models definitely will improve. GPT-4o seems to me at least somewhat better than GPT-4. I've done some benchmarking here. Happy to share results offline if you guys want. But I think systems, LLM-based systems, at least the current architecture we have, they will continue to be unreliable in some shape or form. These are probabilistic systems, right? These are decoder models that are outputting the highest next token that has the highest log prop. So there is no silver bullet here. I don't think this will get solved completely by OpenAI. That's my belief. Anyone disagree here? Okay. I think the path to reliability involves optimizing every single step of the entire pipeline from start to finish. This means making every single prompt robust, actually creating data sets and measuring performance of every single prompt and understanding how accurate or reliable are each of these things. That means using an eval suite to give you fast feedback loops. So when you make a change to the prompt or any part of the retrieval pipeline or any part of your system, you want to get a quantitative sense of how is accuracy improving or decreasing? How is the hallucination rate increasing or decreasing? You can't YOLO this. Once you actually launch products to production, clearly you need an observability layer to understand insights and how users are either using or misusing your product in production. Also very helpful to track token usage, latency, etc. And finally is guardrails, which is preventing your LLM from ever outputting any harmful output to any end user, whether it be a harmful user or someone who is malicious and trying to, on purpose extract PII or other information from your system. So right now, I think all of us here are writing prompts by hand. Is that true? Would you guys say that's true? Everyone's writing prompts by hand? Yeah. I think this is, yeah, it's kind of slow. And it feels like every week there's some kind of new trick that you have to try to get your LLMs to output the style of, in the format and the content, the way you want it to do. It's very manual, very iterative. Sometimes it can be creative, sometimes it's fun. But I think that we will see more and more of people using actually LLMs to write optimized prompts for other LLMs. That's the future that I see here. So we actually shipped a version of this 2 weeks ago. The idea is to describe a high-level task that you want to create an optimized prompt for. Give a few examples of what the input-output mapping should look like. We then create synthetic lookalikes to get a more robust sense of what the mapping should be. And then we use a sampling algorithm behind the scenes to test different prompt variants algorithmically. We use another LLM as a judge to figure out, hey, how well are these each individual prompts performing? And then output the final result. This saves hours of prompt engineering. There's a lot of prompts, by the way, that I've seen that are optimized that I don't think I would have personally been able to write them by hand. It's just not possible to traverse the entire space. So we think sampling and simulation is the way forward for prompt engineering. Let me kind of quickly show you a demo. Describe the task. We extract input-output pairs. These are all examples of input-output mappings for us to understand what is it we're trying to accomplish. We test different prompt variants in describing the task or the examples we're actually using. And we output the final performance. Any questions on prompts or any of this stuff? I think with any stochastic optimization process, it's hard to guarantee that there's a clearly global optimum. I think my claim is LLMs are better optimizers than humans. Maybe humans can add in a better initial conditions, right? The initial sort of heuristics. And we need that. Like, it's not fully autonomous by any means. But I think the only way to optimize is actually through sampling.
I have a question. Like, there's a framework called DSPY.
It's very similar.
So that's what my brain was thinking. DSPY is by Stanford.
Yeah, Omar's great. Omar's a guy from Stanford. He built a package called DSPY. His vision is to create programs as opposed to writing prompts.
Yeah, that's what I was thinking.
I used DSPY and it was very slow. It took me 20 minutes to get the first run. So I was like, this seems very under-executed. So we're trying to basically execute on the same vision. We have the same perspective as Omar. But yeah, you guys should try DSPY. You can obviously try this out too. It's on our website. Free to try.
A follow. So you said an LLM managing another LLM, and then you said giving the examples, right? So where does that data come from? Does it come from human, or are you collecting it, or how are you managing the input for that?
So for the example, to get the examples, obviously humans have to provide, hey, what are good examples of input output? If the examples are bad, you'll get bad output for sure. So for the synthetic data generation to work well, we definitely need human intervention initially. The thing we're trying to free here is people, writing, I'll tip you $1,000, please take this seriously. It's more for my career, blah, blah, blah. These are all tricks to get LLMs to take, think carefully step by step, chain of thought reasoning. We're trying to automate the entire heuristic space completely.
How does this factor in from a cost standpoint?
I would say
You're increasing the token cost, right?
Obviously.
For everyone.
I think it's a trade-off between human time or developer time. So like if you have a developer, suppose they cost $2-$3 an hour, you run this thing, like I'm pretty sure it's a no-brainer. The costs become more, the trade-off and the ROI becomes even more obvious as token costs come down over time. Each run roughly will cost maybe like $5 or $10. But if you were to compete and write the optimized prompt by hand, which we have tried, by the way, competing with our own system, we're usually worse. And it usually takes a lot longer to get to the same output. People just can't write that fast.
use this library like LangChain when you have multiple agents, multiple tools, and the model has a function calls that comes back with the parameter.
Absolutely. This is, I think each component, so if you're using LangChain or Llama Index or any other packages, I think each of the respective prompts, if you have the ability to override them, I would definitely run this through a DSPY or one of our optimizers. So it doesn't really matter. As long as you have the ability to replace the prompt, that is the main utility of this piece. I would optimize each prompt at a time. I would make sure there's a very clear input-output mapping and being extremely good. It's almost like a unit test, right? Every function should perform correctly as opposed to solving the problem completely. So it's decomposing everything into a single prompt, make that sick, and then orchestrate it.
How much prompt engineering does it need your prompt? So you say, describe your task with clear inputs and outputs. So I have to be extremely good as I would be with ChatGPT to have a good output. So how redundant is the in the middleman?
I think the goal is to describe the task. I think if the task is ill-defined, you will obviously get bad outputs, but you would have gotten bad outputs anyway. I think what it's doing is saving you a lot of time in creating a few-shot template, coming up with examples for the few-shot, section of your prompt is kind of expensive. It takes time to find the right set of examples to put. There's a lot of intelligence behind the scenes for how we select the right examples to pick. When we're optimizing, we test the performance on, let's say, 5 examples. We find the examples that it's having a hard time learning and actually use them to define the decision boundary for any kind of classification type task, if that makes sense. For that to be done by a human is pretty hard. You have to use a spreadsheet, right? It's like, oh, I tried this specific example. Here's the result I got. I tried this example. That's not really the best use of time. Great. Okay. Oh, one more question.
So going back to the cost question. So in theory, if I spend time with this first, and then I pick what it says is likely the best one, my initial attempt at chaining 2 agents together will likely go better, and I won't be sitting there cycling through.
Absolutely. Absolutely. That's the vision. That's what we're seeing right now from already usage. Obviously, to build the optimizer, evals is one component, but evaluations are useful in general to quickly run experiments for any kind of RAG agentic type application. So what's an evaluation? An evaluation, people do this all the time, by the way. Let's say you're building a RAG-based chatbot, right? You want to know how well it's working. You'll use your own chatbot. You'll type some questions to see, hey, let me see if it actually knows, can it actually answer the questions. The trouble with this manual approach is you just don't have that much time and you can't cover the entire space. So very similar to the prompt optimization thesis, that LLMs are actually better samplers or better optimizers than humans. The better approach here is to use another LLM as a judge to systematically go through maybe like 10, 20, 100 cases, right, for your RAG-based system and measure the accuracy, hallucination, tone, whatever criteria is important to your task. Actually have the LLM judge flag cases to you. Is it perfect? No, but I think this speeds up the iteration velocity considerably, right? Because now you can make a change. You can swap out a model, right? You can go from GPT-4 to GPT-4o. You can try Opus. You can try Gemini 1.5 Flash, Pro, whatever. And with one command, if you have an eval suite set up correctly, you get quantitative feedback in minutes. That level of speed is, to be honest, how OpenAI iterates so quickly. Evals is all you need. That's basically Greg's motto internally. And I think the same applies for every enterprise. Every single enterprise needs to have an eval suite. This is one example of what an eval can look like. So suppose you have a talk to my documents RAG use case. A single eval run would be taking a question that you want your RAG-based, agentic-based system to be able to answer correctly, pass it in programmatically, get the LLM output, and send it to a judge and have it compare the LLM output compared to what the output should have been. Then you can have it score on different kinds of accuracies, different kinds of criteria. Is it a refusal? Is there not a refusal? You can measure hallucinations if you can pass it contexts, especially in a RAG setting. Any questions on evals?
So this eval, can it be part of a pipeline where you're not, it's all automated, from taking the prompts to evaluating, then feeding back and the loop kind of thing?
For sure. I would say for the prompt optimizer, the eval is autonomously part of the feedback loop. This is more just blowing up the general concept and just highlighting the importance of evals in general. I would say the prompt optimization vision, I don't think really stops at the prompt itself. I feel like if you have different kinds of chunking algorithms, different kinds of data sources, and you actually sample the entire space, one might be able to actually optimize an entire application from start to finish. That's also the DSPY vision, but obviously a work in progress. So prompts and evals generally, offline evals to be precise, they're useful during the development phase when you're trying to build something from scratch, right? Go to 0 to 1. Once you actually launch things to production, it's very important to understand how people are actually using your product. A lot of people I talk to either have no logging or store their loggings in Datadog or just dump it in a DB. But it's very hard to get the entire state, the entire trace for what actually went into being able to answer a specific question. Because usually it's a multi-step flow, right? Someone asks a question, there's a retrieval step, perhaps there's a re-ranker step, perhaps there's a synthesis where you're taking each specific document chunk, summarizing it, passing it to an LLM. It's pretty hard to visualize that if the entire data is just stored, unstructured. So I think you should use a LLM specific observability stack for this. I think one eval that you can actually also add online evals here if you're super sophisticated, where every single log in production can feed through an LLM and output specific patterns that the engineering team or the product team should pay attention to. So for example, if you're measured based on ability to answer quantitative questions, you should definitely be tracking refusals, right? Percentage of questions that your system is unable to answer. It's pretty hard to string search your way through for the word sorry. It's not going to catch everything. And so you definitely need a deeper kind of analytics helper, let's call it. Here's kind of an example. For a specific input, you probably have multiple steps coming through, and I definitely recommend using an observability stack. Any questions on logging?
How do you define the observability? You need a SLI, SLO, and SLA, right? So in this tax for LLM or for prompting, I'm trying to understand how do they define the SLIs and SLAs, because how do I measure, right?
I think the measurement is whatever is available to you. So in this case, if you have a retrieval step, right? You have like a vector, like a pine cone or some DB call, and you're retrieving a bunch of contexts. So what you're storing are the latencies and the actual documents that you stored. It's the what went into it for you to be able to trace the lineage and root cause why a specific output was actually given. That's the main use case.
Yeah, so it sounds like in production or in development, you can kind of check your work, right? What about in production? Do you check what a chatbot is returning for every interaction with a customer?
I think there's certain kinds of scores, certain things you can check for. I think accuracy is very hard to check in production because you don't necessarily always have a known right answer. Like, how do I know, right? If someone's asking a question, like, how do I actually, like, how would an LLM know what the right answer should be? So I think you have to use more classification type, scores there in production.
So probably just very little knowledge on AI here. So once you get feedback from the system, what do you do to go back and tune it? What's the action from the results?
Great question. So in the development workflow, if you have an eval suite, you can differentiate between retrieval errors, if you have a retrieval step, versus reasoning errors, right? Where you gave the information, but it's just like not smart enough to reason its way through and answer the question. So I would say my general heuristic, whenever I see an answer that's incorrect or like a weird output, I instantly do a binary basically search in my brain. Is this a retrieval error? Did I fetch the wrong documents? Or is this a reasoning error? Are my prompts wrong? Or is the model just not smart enough to be able to answer the question? Most of the times, it's a retrieval error, I would say. That's where, you're chunking the documents incorrectly. You ingested some PDFs and some images are missing. So usually it tends to be retrieval, I would say, for anything sophisticated.
So in terms of research, it's really easy to evaluate if your output is correct. So do you use testing models for research where I want to know the latest supply chain disruption within the EV industry? Please give me the article's website and additional resources. And then the output is great information, but all the resources are completely incorrect, depending upon which program you use.
Right. Sorry, what's the question? I was agreeing with you. I was just like, where's the question?
So it's easy to find out if the data is incorrect.
Yes.
Does your program do that more so on a research side versus what is the best shampoo type of thing?
I see. I think that's a domain specific question. I think there's different ways to set up the validation logic for how do we check for facts. I think there's definitely ways to check for facts where the LLM judge can call a search engine for publicly available information. I think for privately available information, you really have to tap into a corpus of facts to do that kind of validation process. So I would say generally it's agnostic. Any kind of eval tool you use, it should be agnostic. It's not very like domain specific, I would say. The last thing is guardrails. Most companies don't really have AI products in production. The AI adoption curve has been surprisingly slow. A lot of POCs, not a lot of things in production for the reasons I mentioned. But as companies start to push out, especially consumer-facing products, you definitely need guardrails, which is basically an internal firewall that you can define your criteria for what kinds of requests you want to deny, what kinds of information you want to make sure you're never outputting. And so that serves as a very important armor, let's call it, for enterprises who want to protect their brand and not end up on Twitter. That's all I had. Prompts, evals, observability, and guardrails. That's what I think is needed to ship products to production that are actually reliable. Any more questions?
This is great. So thank you for the presentation. So what I wasn't sure of, does your app have like solutions for the evals?
Oh, yes. I didn't.
That's what I wasn't really clear on.
It was product placements. I didn't really clarify. Yes, this is our product. We have a prompt optimizer, which optimizes prompts. We have a standalone eval suite, which is used by the prompt optimizer to help gradient descent your way to the correct, final output. We have an observability stack, which actually makes it a lot easier to do evals because now you can start creating data sets, right? To do evals, you need data sets of input outputs. Very hard to do if you don't have logging. So we have logging, and guardrails is coming next. We haven't shipped it because no one has asked for it because people are still not there yet. Got it. Okay.
So I guess this is more like a meta question. Initially, you mentioned that the first step was like POCs, then reliability. I'm not holding you to your answer, but like, what do you think is next after that in this evolution of like AI kind of dominance in within our space?
In what sense? Sorry, I'm missing the.
So the company is saying like your thesis was like reliability is the next thing next year.
Yes.
After that.
I think reliability is a gradient. It's not binary. Great, like is it reliable? Is it not reliable? I think it's sort of a spectrum. And I think just like consumer apps, right? Remember when the App Store opened, a lot of apps were pretty bad. And then people's expectations started increasing. And so I think the same behavior will happen here. Is people are tolerating hallucinations here and there, but I think the margin for error decreases over time. Because what happens is companies who actually take this seriously will build things that are retentive, that are really sick. They will get most of their traffic. All the competitors will be like, hey, we want to also be reliable. And so it becomes this very competitive race dynamics to build systems that are low latency, do more for less. So generally that's the pattern, do more for less. So I think, yeah, things will become crazier.
So my question is your product, right? Can it be deployed in our own data center? Like we don't want like going out or something. Like own LLMs for our data because there is like data.
I totally get it. Yes, the answer is yes.
And can we only do observability or can we do parts of it or we have to buy the whole?
Most people, when they use one component, they end up using all the other three because it just all works synergistically. But if you just wanted one piece, I mean, sure, happy to provision something that makes sense. Any more questions? Feel free to visit Hammock.ai. The prompt optimizer is actually free to try. There's a basic version out there. Give it a try. Let me know how it works. Thank you for having me. That's all I had.
Thank you. Thank you, Sumanyu. Very informative talk. Those 4 topics were really important. One of the topics that he kind of mentioned a little bit when he said chain of thought, right? It's like making things a little bit more atomic, do less, chain things together. There's another type of thought out there as well. Okay, everybody, we are about ready to start up again for our last speaker of the evening. Are we all here? We're almost all here. So our final speaker is a PMG employee. He kind of runs, or he's heavily involved in a lot of our data. I had mentioned earlier that we have a lot of data and we push it around pretty well. I just joined PMG a couple of months ago. And when I was joining, I was, I'm kind of a data guy. So I was pressure testing and looking at the company and how we handle our data and what we do with our data. And what happened was, see, nobody's even listening to me back there. They're just, hey. There we go. So we're about ready to start. And when I was looking at PMG and kind of like evaluating it to see if I wanted to come and work here or not, I saw a couple of workflows around our data and stuff like that. They were actually modeled as directed acyclic graphs, DAGs. And beyond that, they were even done in a little tool called DBT, right? And so once I realized that both of those things were here, I kind of recognized that I've kind of found my people. And some of my people here, Stephen Frazier, he's going to be talking to us about how we've built our data platform, our data plane, if you will. And I'm really looking forward to this talk because I'm still learning about stuff here, and I kind of suspect I'm going to learn more. And here we go, from chaos to context. Stephen, there's the mic right there. Thank you.
Hi, how's everybody doing tonight? Good? Awesome. My voice is hoarse from Memorial Day. Too many pool parties. So we're going to try to keep this straight. Good question. So chaos to context, data control centers, they're a huge, I think, a big idea in my head. I'm still trying to wrap my around it. So thank you all for allowing me to write some thoughts down, use some GPTs to figure out my own brain, which is always a good thing. But before I start, I want to see how many people are in a data science, machine learning type role, data analyst role, vice versa, across the board on a data team. So, okay, cool. Before I start, let's start about myself. So I lead our data engineering team at PMG. I've been here about 6 years. I've seen 10x in employee growth across those 6 years, which is huge. I've seen a ton of growth in our data platform, our marketing intelligence platform, Alley. And I've been wrangling data for 14 years across it, from starting my roots here in Austin in the tech industry. I worked at Hewlett Packard and General Motors up north. And now I am wrangling data here. So if this quote rings a bell, can I get like a thumbs up, high five, woo, yeah, type thing? So almost every single data scientist I know, they're like, I don't get to do cool science stuff because my data is bad. I have to clean it, I have to prep it. And this even kind of goes into how data teams are even measured successfully today within it, right? So we do use dbt in both a core and a cloud fashion here at PMG within our Alley suite. And these are the two biggest outliers from that state of analytics survey they do every year within the data community. So they do poor data quality as the most prevalent problem, which probably kind of goes into why there's some hallucinations in the world, right? And then our stakeholders and all of our data applications across the landscape do not know about data literacy. They don't have anything like my stakeholders don't know what data they need. So I don't know what to build, all types of things. These are the two biggest outcomes across the board. And 72% of all of the people who did the survey evaluated, like, they either get judged on basically a project completion rate or like, did they support a team? And most data teams just support teams, which is kind of cool. And only 5% actually have measured metrics, revenue metrics, SLA metrics across the board. Also, can we please have one conversation in the room, please? Across the board, if you need to have another conversation, please leave. Thank you. So what is a data control center? This is a big context thing in my mind. It's not a single place where you can like turn on and off data, which is kind of what you think of control center, thanks to Craig Federici and our friends at iOS. I think it has components, right? You have storage and modeling components, you have workflows and orchestrations and feedback components. There's an entire data quality component. And the last component I think is metadata, which is probably going to run all of the other components in the grand scheme of things. So we're going to kind of explore those things over the next few minutes to kind of get out of that. So this is what our lovely friends at Dolly think a data control center looks like, depending on the context. So we have the mass scale data control center that you might see at like NASA. Awesome, right? And then we have the short stack, like the one person in their bedroom who runs their own application and is trying to figure out what all their users are doing because they just got the #1 app in the App Store on the bottom right. And then we got a lovely engineer on the top right, just trying to write some code, trying to figure out the different types of control centers. So I think there's a next piece of this around it, and that is the way data is stored and modeled, because this is actually where everything starts. If you don't have the right storage framework or right modeling framework, the rest of it is not going to go so hot. So this is a lovely picture of can anybody guess it? A data lake. That's right. You know, you can ask Dally what the data lake looks like, and you'll get something like this. I like to think of this as something from Westworld, you know, the great or beyond. So the data lake, if you don't know what a data lake is, do you have anybody here who doesn't know what a data lake is? Awesome. Huh? Data swamp is a good word. Yeah. Like data lakes, yeah. Data swamps are huge, right? It's just blobs of data. It's just information. It's just data. There's no actual context to it. File lives here, a blob lives here, PDF's here, images there, right? It's just data. Like there's no info from it. Like it's really hard to manage anything from it. So here we got some older concept on the right, newer concept on the left of a data warehouse, which is just a whole bunch of fun little things that used to be, it came before the data lake, because we thought tables were bad. So we decided that files were better, which in some instances they are. And then we have the new concept is the lake house, which is about the data lake and the data warehouse combined. So they're just new concepts in the industry. They're all the same thing. It's just a place to put your data. Like there's no differences between it besides file formats and semantics across the industry, and try to, got to get your money back somehow. So after the data lands in a lake, a warehouse, a data lake house, whatever it is, the next thing is modeling. Modeling is actually, it has in 3 different components. This is taken from Tech Gadget or Tech Target, whatever. There's conceptuals, which is like putting your business pieces together. This is actually where all the stuff starts and is actually the most important. Because if you don't get business relationships right, you don't know what data to even hit. You can't build logical or physical models across it. So I'm not a data architect, data modeler by trade. I just kind of know that from a business background, I need this, this, and this, and we'll figure out how it goes together around. So all of this requirements, data architects, data modelers, it's all the thing. Physical models is what we all know and love. It's tables and schemas and all the next thing. It's just database management at the end of the day. So next thing is workflows. So you can think of workflows as DAGs or workflows or orchestration engines. And there's tons of tools out there to do that, from the airflows to the prefects to whatever it is. But in the grand scheme of things, workflows do one thing. They take data in, they do something, they put data out, right? You can build data products. Every workflow has components. There's a code runner, a scheduler, logging mechanism. The data comes in, it has metadata, it has raw data come from source systems, third-party platforms, user-generated, which is fun. Unstructured is fun. And then my favorite thing is called Gold Star data. Gold Star data is actually a data product that goes back into another workflow, and it kind of helps. It's a giant cycle. I don't show a cycle here because I'm a mind map guy and not a slide guy, but and then we have all of our data products, whether they're exposures in Excel or Google Sheets or Power BI or Tableau dashboards or, ready for AI data. What does that mean? I don't know. We have reverse ETL. So sometimes data products have to go back into the platforms where they came from, right? So we run ads. So we build data products to optimize our ads, and then we automatically push those back into those various ad platforms, into those algorithms that help our customers get the most on the return on the ad spend. And then there's always these data quality metrics. Sometimes it's record count. Sometimes it's just the status of a thing, a status of a workflow. And then, but this is all of the components of a workflow. And there's things that can go right and wrong around it. But just in general, workflows are data in, data out. Like our friend Sumanyu said, like you gotta know your inputs and your outputs in order to test it. Basically the same thing, right? You can build a workflow that does a lot of stuff, or do you test the single workflow in and out to make things stronger? So data quality means something different to probably every person in this room. From an engineer, it's like, did my data come in? Did it go out? Yes, great. What got dropped? They might not matter. What is the business context of it? And they might not know. But you can't start by measuring everything. So you have to start with measuring what matters. So sometimes it's like number of records in equals number of records out. That might be your very first data quality check. And that is great. As you start to learn about your business, your product, as you start getting more analysis on it, you're like, oh, I'm actually doubling revenue. So I need to do number of records in equals number of records out, and sum of revenue equals sum of revenue going in, right? Across it. So you can do this through data tests. You can do this through lovely Python packages like Great Expectations. There's a ton of data observability and measurement frameworks on the market, but like you have to build it in chunks. You can't build it all at once. And so you might just be like, doing primary key tests this week. Next week, we can go to record count tests. Next week, we can go to next tests. And so as you start getting issues and problems within your pipelines, you'll enhance your framework, your observability, all of it throughout it in order to keep going. And the final frontier of everything is metadata. So metadata is obviously data about data. But data about data means a lot to everybody. And, metadata. It's everything. It's going to all help the brain, the engine, the context layer, everything worked. All of those prompt engineerings and all of that was shown. If you didn't have a ton of metadata and you can use LLMs to generate metadata, it just makes everything better, right? The prompt is probably what matters the most. And if you're building data sets for AI, you have to tell the AI what is in the data set in order for you to get any result from it. Or else it's just going to give you it doesn't even know what your core metric is. So the lovely friends at Data World did a paper last year published in November talking about just SQL design and building out context in a knowledge graph scenario with and without it, right? So without a knowledge graph, very low questions, got 25% rate. When it just had the schema of the tables and some definitions, enhancements of the context grew 3x, 70%. There's a whole paper on archive around this aspect of it, and just giving context to the data, to the LLMs about what is in the tables, what is in the data, can really help matter for users to go from there. So metadata is what's going to drive the future of AI and building data products in the future. And it's not going to be necessarily having the best data model, having the best relationship across it. It really is going to be what metadata can you feed in an engine in order to get the best output for your result. So again, workflow, metadata is probably the most important thing going to the future and everything around it. So when you build a data product, the metadata will go back into the gold star data aspect. It'll get merged with something else. It'll generate the workflow for all the data products and components across it. So next, data context, aka metadata, is probably the next frontier. And nobody likes writing metadata. So maybe we can use some LLMs to create metadata. So that's all I have. So questions. Here we go. Hold on one second.
Saying what you said in the last point, I was hired for a project of making a RAG system work because the one that they built was not working. And precisely the solution that I proposed was leveraging on metadata, precisely to build ML models working with the metadata of the chunk. So then you can build some other kind of association. So definitively, I would say that, yeah, you're right. Metadata is critical to make some things work.
Yeah.
Thanks. So you mentioned that metadata means a lot of things to different people and that people don't like to create it. I'm curious, what do you guys have other sources of metadata that come from your orchestration tool, the workflow tool, or from dbt, obviously? What are some, besides maybe using LLMs to create that metadata or define, could you give me kind of the breakdown between what is metadata that an LLM would help you produce, and then what is metadata that your stack helps you track?
So I think metadata that an LLM helps me produce is probably a template of it, right? I can give it a database table or a final output, and it can be here's all the columns, here's the data types of those columns, here's a generic description of that column based on its name, right? If it's named correctly. The stuff that the LLMs can't do is add business context. They don't know that if I'm working on a Nike data product, that this is what does sport mean? What does shoe mean? What does brand mean? What does this context of their business allow to it? Unless you put in the metadata for that context into the LLM before you generate it. So there's a lot of stuff where a lot of the metadata that we do generate is either generated from, we can ingest the tables and we can write SQL queries that basically give us the outputs of the metadata. So we do a lot of automation that way, where we can automate the metadata generation from other data tables or other aspects through API generations or anything within our Ally platform. Or we just, sometimes you just have to sit down, crank it out by hand. And it's not fun, but it's a one-time thing.
What do you say to leadership to get them to invest in the data operation when data is often just kind of thrown over the fence? Like the software team throws it over the fence. then as long as it's kind of there, people are generally happy. Like, how did you build the platform here at PMG?
Yeah, so our Ally Suite is a big component of our business. It's a big revenue driver. And when we say that we're going to increase, if I can increase query percentage by X%, or I can really get buy-in by like, oh yeah, I don't have to create specialized SQL queries or hire a person to do this. I can build a tool to do it. So it's really more of a identifying this massive problem, like a metadata problem, for instance. If we build this tool, all this metadata, what can we then power? And how much easily can we like turn on a switch for like if a new customer comes on board, how fast can we get a full campaign performance across all ad platforms they're currently running? If we can take that down from 3 days to 3 hours for the past 2 years, that's a good investment. And so it's just a matter of speed between getting an onboarded data to insight is really where we start. We've come a long way, Alex.
Any other questions? No? All right.
Thanks, y'all.
Thank you, Steve. Thank you so much. That kind of wraps up our formal part of the evening tonight. 3 very interesting talks, very interesting speakers engaging. One of the themes that kind of ran through them was hallucinations, right? High quality data might tamp down hallucinations. Testing, prompting, guardrails might help to tamp down hallucinations. And we saw what happens with hallucinations with speech recognition. What I'd like is for somebody to get up here and give us a talk about why hallucinations, why stochasticity might actually be valuable in a machine learning or in an AI workflow system going forward. I think you can actually give that talk. I think you can. And if you want to give that talk and you want a seed, come and talk to me about it. What I'd like to hear right now, before we like break up and stuff like that, is what kinds of topics would you all like to hear, right? What kind of talks would you like to talk? And just because you raise your hand and say, hey, I want to learn about what weirdness happens in high dimensional vector spaces, that doesn't commit you to actually giving that talk, right? I kind of want to know what sorts of talks you guys want to hear. Throw out some ideas, and hopefully somebody is writing these down because we might need them. Oh, come on. What? So what Justin's suggesting is, how does Gen AI effectively feed into the generative creative aspects of PMG's business, but it doesn't have to be PMG's business. It can be anybody's business, right? What does that look like, from like a business point of view? That sounds like a pretty good topic. I knew Justin. I just don't know everybody's name here. So yes, ma'am.
Unless you tell me it's like fully baked into your stack already. It's not. Yeah. Okay. Cool. That's very. I don't think it's full baked into the stack. Exactly. So I would love to hear like part 2. Yeah.
Like specifics in data engineering and moving forward. Yeah. How do data teams use AI? Sounds like there might have been a question of how do we sell data teams to business stakeholders, to the revenuers, right? The people who write our paychecks. That might be a decent subtopic for something. Way in the back. Hype versus reality in production ready applications. A month ago, 2 months ago, we had somebody kind of walk through that, but there's always room for more of that. Absolutely. Absolutely. Yes, sir. Okay, so more about agent-based model or agent-based systems over archive papers, right? What does it actually look like? lang chain, llama index in production, but then moving it into agentic type of workflows, right? That'd be a fascinating topic. Has anybody done that? Has anybody actually taken, there's one guy. Okay, you are signed up to talk. Yeah, Brent. Okay, so how do we close the gap between design and dev work? Not necessarily a data AI thing, but that's okay because this community is not necessarily only scoped towards that, even though it is through AI Camp and stuff like that. AI and UX are actually tightly coupled, and we should be able to talk about those sorts of things. Okay, a map of how AI influences or impacts various roles inside of a organization, a workflow, a work, or something along those lines. Yeah. You got one over here first. Hold on.
Using AI can impact your meeting, because let's say if generative AI generates some code for you, and that code is already in the open space, but it's copyrighted or patented. You know, use that. So what are the legal aspects?
So yeah, so kind of another aspect of brand safety. What are the legal aspects of using Gen AI, either in code generation, but also, hey, maybe ad generation or something along. We probably didn't use AI to generate that, but in general, you know, what are some of the legal aspects, and what kind of exposures might we have? Hot take by me, not by PMG. Why not just let the market decide? Hot take. We'll just let that one go. Yes, Anna. AI ethics. What's the evolution look like, Stephen? Okay, so kind of related, sustainability, environmental concerns about AI. I know we talk about that a lot here in PMG. We actually have guidelines and rubrics around that sort of stuff. Back to ethics. Does anybody know anybody from the computer science ethics department at UT? Because they could probably answer that question. They'd be a great speaker. So if anybody's got lead-ins there, that would be awesome. Ethical and responsible AI, part of that, right? How do you draw that line? Do you draw that line? Sure. Yes, the answer is yes. Yes. Is your, you know, what is the business landscape going to look like, right? One of the things with all these GPTs and LLMs out there, right? They're billion-dollar corporations behind them. We mere mortals have no chance to there. The only thing we can do is try to develop something that they're not developing, but we're always at risk of them coming in and doing it, or somebody else, right? But it's, what was that? Maybe they'll buy you out. Maybe they'll buy you out. ML ops, right? Yeah. So ML ops, you know, how do you govern the data? How do you observe the data? How do you detect drifts in the data, right? I mean, frankly, if you're going to put an ML system into production, you want to change behaviors. How do you detect that? How do you know when the ML system has done its job, right? Because it should, right? That's what you're trying to do. Those sorts of ML ops types of questions. Yeah, that's a good one. They're all good ones. They're beautiful, brilliant question. Brilliant. I mean that. Any other questions? Or any other topics, I guess. Okay, this is a great thing. Hopefully we got a lot of them recorded. I'll remember a few of them. We're going to be here. Doors are open for a while. Now, you know, let's build that community. But before we do, the 4 things that I asked of you all, right? Link in with people, take photos, send them out. come back here on 6/27 for the next one. If you're up in Dallas, 6/25, you can do them both. I don't know if you want to. If you come back here, think about bringing a friend. If you come back here and if you brought a friend, think about giving a talk, right? We just had a bunch of ideas for talks. We got 4 weeks to put one together. You can do it. I know you can. Jason, you got it, man. You got it. All right. Thank you so much, everybody, for coming, and enjoy yourselves.